Hey, it's Mr. Hayashi with Geometry 3.2, Parallel Lines and Transversals. So hopefully you watched the 3.1 video and know what a transversal is, first of all, and then also all the different pairs of angles, like alternate interior angles, alternate exterior angles, and so on, because you'll need those terms in order to understand 3.2. So in 3.1, we talked about two lines intersected by a transversal. In 3.2, we'll get a little bit more specific and then go over two parallel lines intersected by a transversal. If I could draw things correctly, let me draw that a little bit better. But if I have two parallel lines, I'm going to try to make this somewhat of a horizontal line. I'm just going to call that line L. A second line, line M. If line L is parallel to line M, I could show that in my diagram by adding an arrow here. I could make two arrows here and two arrows here. That shows that the two lines are parallel. If I have a third line and it intersects both of those lines, this line T is the transversal. And in that diagram, since line L is parallel to line M, I could write it like this as well. Line L is parallel to line M. Really, there's only two different angle measures in the entire diagram. Okay, for example, if I knew the measure of this angle right here, I measured it, let's just say it's 70 degrees. Okay, then for these top four angles right here, this forms a linear pair with this angle, so they have to be supplementary, which means they add up to 180 degrees. This would be 110 degrees. And I could repeat that process. These two angles form a linear pair, they're supplementary, or I could use the vertical angles congruence theorem. This angle is a vertical angle with this angle, and then they would be congruent. So this is 70 degrees, this is 110 degrees, because it forms a linear pair with either of the 70-degree angles, or it's vertical. And then, especially since these lines are parallel, it wouldn't be the case if they are not parallel, but this angle, 70 degrees, is congruent with this angle. And that actually comes from the corresponding angles theorem. We'll talk about that in a second. And then I can kind of repeat the process as far as how we found the measure of all of the angles on the top part of the diagram. We can find the measure of each of the angles in the bottom part of the diagram as well, using linear pairs and then the vertical angles congruence theorem. But like I said, there's only two different angle measures in the entire diagram, 110 degrees and 70 degrees. If you notice, so I was talking about these two angles right here, this 70-degree angle and this 70-degree angle, those are corresponding angles. Those two angles are congruent. 70 degrees is the same measure as 70 degrees. So the corresponding angles theorem is if you have two parallel lines, so again, the prerequisite there is that the lines have to be parallel, are either cut or intersected, same thing, by a transversal. Notice how I'm writing this as well as a conditional statement. I think I spelled transversal incorrectly, so I'll spell it correctly here. Transversal. Then, specifically, corresponding angles are congruent. So the angles that I circled are corresponding angles. Those aren't the only corresponding angles in the diagram. Those are not the only congruent angles in the diagram either. Okay, this 110-degree angle right here corresponds with this 110-degree angle. Those angles are congruent, and so on. These 70-degree angles are congruent. These 110-degree angles are congruent. And then if I look at a pair of alternate interior angles in the diagram, okay, has to be between lines L and M. Everything in here, without actually shading it, are the interior angles. But this 70-degree angle right here is alternate interior with this 70-degree angle. So you could probably make the conclusion that if two parallel lines are intersected by a transversal, then alternate interior angles would be congruent. So I could start off my conditional statement the exact same way as I did theorem 3.1. You have to have two parallel lines intersected or cut by a transversal. then your alternate interior angles would be congruent. Just rewording it a little bit differently now. They're intersected by a transversal instead of being cut by a transversal, although that means the same thing. So by alternate interior angles being congruent, that means both pairs of alternate interior angles are congruent, although not all congruent with each other. I'll show you in a second. So I know I don't have these angles numbered in the diagram. I circled these two alternate interior angles. They're alternate interior angles with each other. They're congruent. They're both 70 degrees. This 110-degree angle and this 110-degree angle are alternate interior angles with each other. Those two angles are congruent. So both pairs of alternate interior angles are congruent. They're just not all congruent with each other.